Hey, what's up? I'm Dave Boyer, aka Mr. Boyer, aka the Swamp Man. My newly created studio in my house during this school shutdown from the coronavirus. So bear with me in this tight space, but I've tried to make the best of it and teach you a lesson about earthquakes today. So let's take a look at our lesson objectives. Our first objective is going to be to understand where earthquakes are happening. That earthquakes primarily are happening at plate boundaries. Then going to look at what actions are causing the forces on the rocks. These forces get rocks to shift, get rocks to move, and those movements are what an earthquake really is. The earthquake is the waves, the energy that moves out from the shifting of large pieces of rocks. Then our last step is going to be to identify the three main types of faults. So you're going to need a page to set up in your notebook for this. I would title it at the top, Earthquakes, and then break it into three sections, because our sections are going to be about these three main faults. So if you want to pause the video, you can do that and resume it once you have your page set up. But I'm going to keep moving forward. All right, so as we look at my model that I have here, I've got our chunks of rock that are here. And I can use these to hopefully demonstrate some of the action at each of these, during each of these types of faults. So hopefully you've looked at maps of where earthquakes are happening. And if we looked at earthquakes over the last 15 years, over the last 100 years, over the last 1,000 years, the majority, 99% of these earthquakes are going to be happening, especially the major earthquakes are going to be happening directly on a plate boundary where the rocks are moving, where they're interacting with each other. So each of these plate boundaries does different things to the rocks, and we're going to look at each of those situations. So the first type is called a normal fault. So in that first section of your notes, you can title that section Normal Faults. You'll record all the information that I have on my paper here that I'm going to go through here with the models. So the first thing that it lists is that normal faults occur at divergent plate boundaries. I'm hoping those types of plate boundaries are starting to make sense in your head now, but just as a quick little look, divergent means to separate apart. So we've got plates moving in opposite directions. As those plates pull apart from each other, I'm going to try to set my camera down so I can have both hands to do this. See if my studio is set up for this the right way. So as those plates start to pull apart from each other, it's going to crack the Earth's surface, the crust, in different spots. Every one of those cracks can be a small fault, or over a large area we have fault zones. So as they're pulling apart, we might get this pieces to crack into some separate chunks of rock. But just cracking by themselves isn't going to cause major earthquakes. We need whole chunks of rock to move to make our earthquakes. So in our divergent plate boundary, I'm going to try to pull apart my two hands. I've got that block in the middle that's free to move. I'm not holding on to it. So as I start to pull those blocks apart, the rock slides down. So that's a normal fault that occurs at a divergent plate boundary. We have rocks pulling apart, and then some chunk of rock between them has now room to slide down, and it fills that space as the plates are pulling apart. So in a normal fault, we get shapes like this. We might get lowered areas, but often we're going to see that these are going to lead to ridges and mountains or slopes on the sides there. So let's talk about the forces involved. Each one of these types of plate boundaries that are creating these types of faults is going to give us a different type of force acting on those rocks. So when those rocks are connected together and the plates are trying to pull them apart, that's going to create the force of tension. Again, tension can be like thinking of a rubber band, something stretching out wider, longer. It's increasing that potential energy, that force that it can use to activate and turn into kinetic energy for those rocks. So tension is this force that led to the movement down of the rock as that rock's being pulled apart. In case you didn't get all those notes, let me give you a quick look at my paper of it. Again, you can pause to copy your notes, but I'm going to keep moving forward. All right, so normal faults. These words are kind of strange. There's nothing normal about a fault, but they're called normal faults because they happen, in many places around the world at divergent plate boundaries. The opposite of a normal fault is called the reverse fault. So the second section of your notebook, you should title Reverse Faults. So like I said, the reverse fault is the opposite of a normal fault, and it happens at the opposite kind of a plate boundary. So the reverse fault is going to occur at convergent plate boundaries. Convergent means come together, so our arrow should be pointing towards each other. Our plates are going to be moving towards each other. As you can see in the diagram, and I'll demonstrate for you here in a second, if the plates are moving towards each other and they crack the crust to form a fault line to allow for the independent movement of some rocks, we're going to see that rock in the middle gets squeezed and pushed upward. And then I'll come back and talk about that force of compression by the end of this. Let's see if I can't set my camera down again for a minute. So same three blocks of cardboard for this model. Again, we've got a plate boundary, a convergent plate boundary where two or more plates are coming together, and the forces involved are pushing those plates towards each other. You can imagine being this middle block stuck between two giant continents that are being pushed hard by convection currents in the mantle. That's going to apply a lot of force to that middle section. And that force is going to be the force of compression, to squeeze or to push on each other. Let me try to catch this real quick. Sorry about that. All right, so as the forces from the plate on the left and the plate on the right are pushing inwards towards each other in a convergent boundary, the rock in the middle is going to get squeezed or compressed, and at some point, that potential energy of that squeezing is going to release into kinetic energy, which is the earthquake. So as they're pushing, eventually we can get it to pop up like that. And that is a reverse fault. This is the most common type of fault that leads to the formation of mountains. As you can see, block moving up, straight up, is a good sign of a mountain formation. Going back to those 5 types of mountains, the fault block mountain, remember about some of those terms and some of the classic shapes of a fault block mountain. We have our top piece, the horst, then you have the scarp, the straight down, sometimes even dipping inwards like Hanging Rock is. Go for a nice hike and check that out. And then you have the graben at the bottom. I'm not great with those 3 terms, horst, scarp, and graben. I might be missing one of those, but you won't be tested on them. They're just kind of words that are good to know for the future. But reverse fault is something that you should know about. We have reverse faults that occur at convergent plate boundaries. The force involved is compression, and the compression of the 2 plates pushing into each other causes the rock in the middle to move upward in a reverse fault. All right, we got one more to get through. Quick look at reverse faults. Again, in case you didn't get all your notes copied down into the middle section of your paper, you can pause now and record that information. But I want to move on to the last type of a fault, a strike-slip fault. I'll try to give you a good look at the paper. Again, you can pause it and take your notes now and then continue watching the video after it. strike slip faults are probably the types of earthquakes that are most often kind of thought of and prepared for, primarily because these happen at transform plate boundaries. And the most active earthquakes in the United States are along a transform plate boundary, the San Andreas Fault. So we get a lot of these types of earthquakes. And depending on how much the rock moves, they can be really powerful earthquakes. So they can definitely cause a lot of damage. So again, they occur at transform plate boundaries. Remember back to our plate boundaries unit, we've got transform means that they're moving in opposite directions side by side. They're going to rub on each other as they are sliding past one another. So try to draw that with my 3D blocks that are right here. I'll try to demonstrate that with my cardboard block models in a minute. And the force that we have there is the force of shearing. Shearing is a word that really kind of means to cut. We think of maybe like sheep shearing a sheep, is cutting the wool off of a sheep. Pilots often think of wind shear as they're coming into landing when the winds are at different directions at different altitudes. So they might be coming down through 2,000 feet of elevation heading down towards the runway, and the wind's blowing one direction. And then all of a sudden, once they drop down to 1,500 feet or 1,000 feet, the winds completely change directions down at a lower elevation, and that can be a really difficult thing for a pilot. So that shearing means that the winds are moving at two different directions. They're like rubbing and breaking on each other. So shearing in terms of rock is going to be that the rock stuck between the boundaries, the plate boundaries of our two moving plates, they are going to be rubbing on each other. They're going to stick to each other, and they're going to kind of hold and resist that movement, but they give way suddenly in the form of earthquakes, and then they rub and break apart in opposite directions, and that's our shearing. So let me demonstrate that real quick. Often it's easiest to see this from looking at it from above. So we've got our landforms there, a creek running through there, a river running through there, our two plates that are here, and they're going to be moving in opposite directions beside each other across the plate boundary. So one of the plates I'm going to move upward, the other plate I'll move downward, and as they're sliding, they're stuck together. The jagged parts of the rocks of the plate boundary are kind of holding in onto each other, resisting that movement. But the convection currents in the mantle are going to win in this battle, and they're strong enough to eventually cause that rock to suddenly move. And that sudden movement is our earthquake. We see that the movement of the plates are sliding past one another. You have that force of shearing in between the two plates of rocks, and we're going to have a sudden movement or an earthquake. And that wave energy can move out throughout the entire planet. So those are our three types of faults with the three forces that are involved in causing that action or the result from that action. First video I've shot up here in my studio to try to teach a lesson, but I've enjoyed it. I'm going to head down the ladder in a minute. Maybe go check my email, and just wanted to stop and share it with you and tell you science rocks. Peace.